Hello everyone, welcome back to our channel. So in today's episode, we are going to be dealing with one of the most important topics in mathematics, which you particularly learn it in the second PU. So that is, today we'll be discussing about integration. So now commonly integration is also called as your, let's change the color and write, called antiderivative. And now, in solving integration based sums, we use three important methods. That is, integration by the method of substitution. So, this is the first method. Second method, which we will be solving the integration sums, will be on the basis of the partial fraction method. This is the second method. And last and third one is the method which is by parts. So let me repeat it again. So basically we solve all the integration based sums using these three important methods, that is by the method of substitution, by the method of partial fraction, as well as by the method of parts. But today we'll be dealing with the first method, that is by substitution. So under substitution, let me give you few examples of sums which can be solved using the substitution method, like the integral of tan x dx, integral of cot x dx, integral of secant x dx, as well as let's consider another example, cosecant x dx, and so on. There are many more. But for today's class, we'll be dealing with the first example, that is integral of tan x dx. So let's see. So now let me change the color again. We go with black. So first one, we have to find out what is the integral of tan x dx. So I have to find out the result. So now, as we know that usually if we have anything like integral of secant square x dx, we know that the answer is tan x. But then when we are trying to find out the integral of tan x dx, you may notice that there is no particular formula based on it. So therefore, if in such cases where we are not having a ready-made result or a formula based one, in that case you can opt for any of the three methods, and you can do this particular question can be solved using the substitution method. So let's get started. So now let's start. So now I'll just rewrite the question again, that is integral of tan x dx. We know that the integral of tan x can also be written as, since tan is a combination of the ratio of sin x by cos x. As it is, I write dx. So what have I done? So in place of tan x, I've just written it in the other form, that is integral of sin x by cos x dx. So now this is a very important part of the substitution. I shall either substitute the numerator, that is sin x, or cos x, which is the denominator, with the letter t. So now, how will I get to know which one to substitute? So let us take an example. If I substitute it as, if I take sin x, that's the numerator, as equal to t, the basic rule in substitution method is to be considering this as the equation number 1. Now when I take sin x is equal to t, I consider it as equation number 1. Now I'll be differentiating equation 1 equation number 1 with respect to the letter t, okay, which means on differentiating sin x we get differentiation of sin x will be cos x dx by dt equal to dt by dt, that is 1. So now I'll express it in the form of dx. So dx is equal to dt by cos x. Consider it as equation number 2. So now what I'll do, I'll be substituting equation 1 and 2 over here. So actually we are just checking which one can be substituted as t. It's not necessary that you'll be landing up with an answer. I'll continue here. So I'll take it as, here I'll write integral of sin x. What have we taken cos x as? Okay, sorry. Sin x I have taken it as t. So let me just erase it. Okay. So I've taken sin x as t, so I place here t. Here I have cos x. Now in place of dx, what have I taken? dt by cos x. dt by cos x. So now if you notice, what will we get? We'll get integral of t by cos square x dt, which means that we cannot further do the integration because cos square x particularly doesn't have any definite result. So therefore, which means that the sin x to be substituted as t will be considered as wrong, which means that if sin x uh, doesn't satisfy, that means if it doesn't lead us to a particular result, then in that case we opt for the other one, that is I'll be considering the denominator. So I did this in order to show you of how do we decide which one to be taken as the correct substitution for the variable t. So now let me continue with cos x. So now this was the particular result which we saw in case of sin x substituted as t, which means that particularly sin x cannot be taken as t. So now let me just show you using cos x. So let's take it as, so let cos x be equal to t. I'll consider it as equation number 1. Clear? So now we'll be differentiating equation number 1 with respect to t. With respect to t. We know that differentiation of cos x is nothing but it is minus sin x dx by dt equal to dt by dt, that is 1. Let's express this equation in terms of dx. So you get dx is equal to dt by minus sin x. We know that minus, if minus is in the denominator, you can bring it up to the numerator. So I'll write it as minus dt by sin x. So both are also the same. So let's conclude it as dx is equal to minus dt by sin x. I'll call this as equation number 2. So now let's substitute equation 1 and 2 in the, in which equation? In this particular equation, let me call it as equation 1a. Okay, this I call it as equation 1a, and this one I'll call it as equation, okay, let me call it as equation 1b for our understanding. So now we'll be substituting equation 1b and equation 2 in the first equation, that is in the equation 1a. So let's substitute, which means we get integration of, that is integral of, what have we taken? Sin x by cos x dx. So I've substituted cos x as t, so I write it as sin x as it is. In place of cos x, I take it as t. Now if you notice, we have written it as dx. So in place of dx, I shall substitute dt by sin x. Okay, dt by sin x, and of course minus symbol. But then now if you notice, minus dt can be written as minus 1 into dt, which means that minus 1 is a constant, so I'll bring minus 1 outside. So minus 1 is same as minus, and this will be plus. So therefore we take out this particular thing outside, that is minus 1 or just minus outside. So now what do we get? Okay, we'll take it with red. What do we get? We get it as minus integral of sin x, I'll rewrite it, sin x t by t dt by sin x. I hope you understood why are we taking minus out, because here we get it as minus dt by x, that is minus dt by sin x. Now minus dt can be written as minus 1 into dt is same as minus dt. So therefore minus 1 is a constant which we already know, and whenever we are taking the integral of a constant we bring it out. Similarly, I have taken out minus 1 outside, put it over here as minus 1 or just minus. If you notice, sin x gets cancelled. We are left with minus integral of 1 by t dt. But then we know that the integral of 1 by t is nothing but log mod t plus c. C is the arbitrary constant. So which formula are we using? So you may be knowing that integral of 1 by x dx is nothing but it is log mod x plus c. So in place of x, we are using t. Same thing I have written, that is 1 by t dt equal to log mod t plus c, arbitrary constant. But then this is not the final step. You should remember that we have considered something as t. That is, I have considered cos x as t. So wherever t has come, I will substitute cos x. So minus log, in place of t, I'll put cos x plus c. If you notice this particular area, this particular expression, we are already familiar with this one, that is log m power n is equal to n log m, which means that over here what do I have, it is minus log mod cos x. Can I consider this minus as minus 1? If so, we can express this in the form of log m power n. How will I express it? I'll express it as log mod cos x to the power of, or let's say minus 1. I'll write it a bit clearer for you. Okay. How can I write it? Okay. I'll write it like this. Log mod cos to the power of minus 1, same. But over here we won't call it as minus 1 particularly. We'll call it as cos inverse x. So therefore, can I replace it with this particular expression? Yes. So instead of minus log mod cos x, I'll be writing log cos inverse x. So this is nothing but this, you can, for your understanding, you can call it as minus 1, but it's actually cos inverse. Cos inverse is nothing but, let me make a box for you. So cos inverse is nothing but it is 1 by cos x. 1 by cos x is nothing but it is secant x. So let's write it in two steps. So this becomes log of mod cos inverse x plus c, or it can be written as log. We know that cos inverse is what? 1 by cos x, which is equal to secant x, sec x, which is equal to log mod of sec x plus c. So therefore, we finally land up with our result, which is the result for integral of tan x dx. So let me write it as a conclusion. Okay, so therefore what have we learned? We have learned today that the integral of tan x dx is equal to log mod of cos inverse x plus c, which can also be written as log mod secant x plus c. Why secant x? Because cos inverse x is nothing but 1 by cos x, which is also called secant x. So this is our today's learning. So similarly, just like how we use the method of substitution for finding the result for integral of tan x dx, similarly you can do the same with respect to integral of cot x dx, integral of secant x dx, as well as integral of cosecant x dx. So please do like this video, subscribe our channel, as well as do follow our account on Instagram. Thank you for watching.